My dear brothers and sisters, I welcome us to this my YouTube channel. Today we are going to discuss on the how to solve some calculus. I'll be concentrating on integration, and the kind of integration we are going to do today is integration by parts. Integration by parts. I will explain it more with examples. Especially when we are given two different parts of an integration, we have a formula to do it. Now, the first thing we need to know is that we have u and the du, we have also dv and then v. The one you call if you, for instance, from this very question given now, this one that I have highlighted now, the first part, that is the x. If you make x your u, then ex dx becomes dv. And another one, if I make ex my u, then x dx becomes the dv. So I believe that when you follow, just pay full attention. When you follow up, the explanation will be very easier with examples. So now, x e raised to power x dx. Now I will first of all make x my u. So u is equals to x. Then du means that I'm going to differentiate x. And if I differentiate x, I have 1 dx. And the next thing I have to do is now dv. dv means the remaining part of the remaining part of the question, that is ex e raised to power x dx. And then v means what is the value that if I differentiate, I will get ex dx. That is what v is. As well, that means what is the integration of ex dx. The integration of ex dx is the same thing as ex, that is e raised to power x. So we now have the format now, u, du, dv and v. So now we are going to put it in the formula. The formula is the integration of u dv is equals to uv minus the integration of v du. So I continue, then we just add the parts to the formula immediately. uv is equals to x, I use green color, equals to x e raised to power x minus the integral of e raised to power x du is equals to dx. I have now represented the values now. E raised to power x, first of all, x is u, e raised to power x is v. Then I repeated v again, e raised to power x, and then du is 1 dx. So I don't need to write 1, I just write dx. So bringing down this now, I now have x e raised to power x minus, if you integrate e raised to power x, what you still have is e raised to power x. You now have e raised to power x plus c, and that's the final answer. So stay tuned for more. We have more to discuss today. Now we have seen this question, x squared ln x. Let me say it now. Whenever you see ln x, the best thing you do is to make it u. So let our u be ln x. ln x. Then our du, if you differentiate ln x, what you get is 1 over x dx. Then our dv is the remaining part of the equation, that is x squared dx. And then our v means the integration of x squared. And if you integrate x squared, what you will get is x cubed over 3. Now we add it to the formula. uv means ln x ln x into x cubed over 3 minus the integral of x cubed over 3, then du is 1 over x dx. So now when we meet something like this, what you need to do is very simple. You let one x cancel one x. Then we now rearrange the equation. We now have x equals to 1 over 3 x cubed ln x minus, when you integrate x squared, what you have is x cubed over 3. So now we continue, we bring down 1 over 3 x cubed ln x minus 1 over 9 x cubed plus c, and that's the final answer. Now we have to solve this one too. X sine x dx. Now we make x our u. So u is equals to x. The du becomes 1 dx. dv becomes the remaining part of the question, that is sine x dx. And then v means the integration of sine x. The integration of sine x is equals to minus cos x. Then we add it to the formula now. uv means x minus cos x minus the integration of minus cos x, then dx. What we have now is we have to rearrange the question now, or the answer. We have to rearrange it now to have minus cos x minus, sorry, it's going to be minus x cos x minus x cos x minus, when minus meets minus, it becomes plus the integration of cos x. When you integrate cos x, we now have sine plus sine x plus c, and this is the final answer. Now we have to solve this one too. Ln x dx. Like I say, whenever you see ln x, you make it your u. So our u becomes ln x. Our du becomes 1 over x dx. Our dv becomes 1 dx. Then our v becomes x, because if you integrate 1 dx, you now get x. So then we add it to the equation. U dv is equals to uv minus integration of v du. uv is equals to ln x multiplied by x minus integration of x du is 1 over x dx. So this x, we cancel this x, we have only 1 dx. So you now rearrange the equation. Let's see how it looks. Now have is equals to x ln x minus, if you integrate 1 dx, what we get is minus integral of 1 dx. So now equals to x ln x minus x, because when you integrate 1, it becomes x plus c. That's the final answer. We now have another question now. X squared sine x dx. First of all, which one do we make our u? Let's make x squared our u. Our u is equals to x squared x squared, then du becomes, if you differentiate, becomes 2x, and then dv, the remaining part, that is sine x, and then v becomes, if you integrate sine, you get minus cos, equals to minus cos x, and then we now add it to the formula uv, that is x squared multiplied by minus cos x minus the integration of minus cos x, then our du is 2x dx, it's equals to 2x dot 2x dx. So what we do now is we rearrange the equation, and it's now equals to, bring the minus first, minus x squared cos x minus, now bring 2 forward, minus 2, but because we have minus and minus, it's going to be plus 2. The integral of minus integral of cos integral of x cos x dx. Now the next thing is to do the integration immediately. Now there is a problem, not a problem, we need to do, because we have x cos x, we have to do another integration by parts again. So this is very well, I'm going to integrate it again, and this time around our x will now be, our u will now be x equals to x, and our du will now become 1 dx, and the dv becomes the remaining part, cos x, and then our v will now become, if you integrate cos, you now get sine x. So you have to add this into the equation. We now have minus x squared cos x plus 2 into du uv is equals to x sine x sine x minus the integral of sine x again, sine x, and then du is 1 dx, sine x dx. Now continue, minus x squared cos x plus 2 into, you don't need to make it into again, just 2x sine x minus, let's distribute these two, minus 2 sine x is, if you integrate sine, you get minus cos. So it's going to be plus. Plus 2 cos x plus c. And that's the final answer. What you do is to look around to know whether there is any way we can combine like terms. Here there is no way to combine any like terms. The only thing we can do is nothing. Just leave the answer like that. Now go to the next question. The next question is asking us x squared ln x. The one we saw before is x squared sine x. This one is x squared ln x. For x squared ln x, our u will be ln x, like I said. D will become 1 over x dx. And then dv becomes the remaining part, x squared dx. And then v becomes, what is the integral of x squared? X squared is s cubed over 3. So we now add it to the formula. It now becomes equals to the integral of x squared ln x dx is equals to uv is ln x multiplied by x cubed over 3 minus the integral of x cubed over 3. Our du is 1 over x dx. So whenever you meet something like this, let this x cancel this x, 1x there. We now have to rearrange the equation again and see where it leads us to, which is equals to 1 over 3 ln x over 3x cubed ln x minus the integral of before the integral I need to bring out this constant, 1 over 3 integral of now x squared dx, because this x will cancel 1x, which is now equals to 1 over 3 x cubed ln x minus 1 over 3. If you integrate x squared, what you have is x cubed over 3 to multiply by x cubed over 3 plus c, which is now the final answer now becomes 1 over 3 x cubed ln x minus 1 over 9 x cubed plus c, and that's the final answer. Now for this question, x cubed ln x dx, our dv, our u is always, as you know, our u is always ln x. Du is going to become 1 over x dx, then dv becomes the remaining part x cubed dx, and then our v, it becomes, if you integrate x cubed, you now have x raised to the power 4 all over 4. So we have to add this to our equation. Now what we have here is we need to put it the integral of x cubed ln x dx is equals to u is ln x x4 x raised to the power 4 over 4 minus the integral of x raised to the power 4 over 4, and then du is 1 over x dx. So as usual, this one will cancel. So we now have equals to ln x. Now have equals to 1 over 4 x raised to the power 4 ln x minus the integral of 1 over 4 x raised to the power 4. No, this one will now be x raised to the power 3 because 1x has been cancelled. Raised to the power 3 dx, which is equal to, we continue, 1 over 4 x raised to the power 4 ln x minus 1 over 4 integral of this. If you integrate x cubed, we now have x raised to the power 4 over 4. So we now combine like terms. We now have 1 over 4 x raised to the power 4 ln x minus 1 over 16 x raised to the power raised to power 4. So that's the final answer. Now let's know if we can finish this one within the short space, otherwise you can copy it out and then solve it in another place. Okay, now I copy this one, solve it here. I think this space will be enough for it. Now, being given this question now, now find what is our u and so on. Okay, now the integral of u dv is equals to uv minus integral of v du. So we now find which one is u. U is equals to what? What do we make our u? Normally, let's make EAX our u. EAX our u, and then du now be equals to, if you differentiate this, now becomes A E A X. Then our dv become the remaining part, which is equals to cos bx dx, and our v, remember v is the integral of cos bx dx. So if you integrate cos, now get sine, so now becomes equals to, now becomes sine bx over b. So this is the format. This is the, we have now gotten the parts of it. So now put the parts into the formula. What we have now is uv, that is EAX v multiplied by sine bx over b minus the integral of sine bx over b. Then du is A E raised to power ax. So now we continue. E raised to power ax over multiplied by sine bx over b minus if you integrate sine becomes no at this point again we need to do another integration by parts for what we have. So minus 1 over b minus a over b So now, what we need to do now is this very one that I have highlighted now. We need to solve the integration by parts again. So what we do now is we have to find b, find the parts. Then u will be equals to, let me change the color. U is equals to the same thing. Let's make u EAX. Du is equals to AEAX. Then dv is the remaining part, that is equals to sine bx dx. Let me write it clearly. dv is equals to sine bx dx. Then v is equals to the integral of sine is equals to minus cos, bx over b. So now we have to continue with the solution of the problem. So the integral of e raised to the power ax cos bx dx is equals to, now we bring down these values we already have, e ax sine bx over b minus a over b integral of sine, no, before this one, now I need to distribute a to now this sine bx eax, we need to find the solution by parts. U is eax. We now have eax, and the v is minus cos bx over b, the minus the integral of minus cos bx over b, and then du is equals to a e raised to power ax, so which is now equals to, and you have to write it again, e ax sine bx over b minus a over b, which is distributed into this. So when this one is distributed, then this one is going to be plus a over b e a x cos bx over b. Then this minus here will cancel this minus, but because it has a over b, it has also minus sign. It will also maintain the minus sign again. Now have minus a over b integral of because it has a over b, now becomes a over b squared integral of a e you have taken a already, integral of e ax e raised to power ax cos bx dx. So now if you take a closer look, what we have here now is the same thing as what we are having here. So otherwise, if we keep on doing the integration by parts, it will become ad infinitum. It will not have any end. So we have to transfer this one this value at the left side, at the right side, to the value at the left side. Just look at the solution. So what we now have is when we bring this one here, when this one crosses over to this side, it now becomes a over b all squared to integral of e raised to the power ax cos bx dx is equals to, now write the remaining ones of this one like this, equals to e ax sine bx over b plus a over b e ax cos bx over b. So now to get the correct value, you have to multiply both sides by b over a squared, half b over a squared. So if you add it to both sides, you now have this one will become free now. Now have integration of e raised to power ax cos bx dx is equals to, now we now have b over a all squared multiplied by 1 over 2 into e raised to the power ax sine bx over b plus a over b e raised to the power ax cos bx over b. This is the final answer. This. So, thank you for joining us for today. This is where we have to bring it to an end. See you guys next time.